Imagine our solar system as a bustling metropolis. Until recently, we only knew the local residents, the planets, asteroids, and comets orbiting the sun. But in recent years, 3 intergalactic tourists have come to visit us from the depths of the galaxy. And if the first 2 were strange yet understandable, the third arrived in a way that made scientists seriously wonder, is it really just a comet? With each day of observation, this interstellar visitor surprises us more and more. What is so unusual about this traveler that journeyed for billions of years to reach us? Is it merely a common comet, or something that could forever change human history? I'm Dr. Leonardo Costa, and this is the Space Podcast. Subscribe here to get the latest news from the cosmos. In 2017, the first visitor arrived, Oumuamua. It was shaped like a cigar, about 400 meters long, roughly the length of 4 soccer fields, and was extremely thin. It didn't have a tail of gas and dust like a typical comet, yet it accelerated in a strange way, as if something was propelling it. Its peculiar shape and behavior spawned countless hypotheses, from a fragment of exotic ice to a piece of an alien spacecraft. In the end, most scientists agreed it was a natural object, rare but natural. In 2019, the second traveler came, Comet Borisov. This one was much clearer, a classic comet. As it approached the sun, it released gas and dust, forming a bright tail. Its nucleus was about half a kilometer across, the size of a large skyscraper lying on its side. Borisov was exactly the kind of visitor astronomers expected to find. Then, in 2025, the third one appeared, 3I-Atlas. From the first observations, it was clear this was something completely different. The first thing that grabs your attention is its incredible size and mass. Imagine a mountain, not a hill, but a true giant like Everest. The nucleus of 3I-Atlas is over 5 kilometers in diameter. That's 10 times larger than Comet Borisov and taller than Mount Kilimanjaro. But the most impressive thing is its mass, over 33 billion tons. To picture that, imagine 100,000 of the world's largest cruise ships fused into a single solid block of rock. That is 3I-Atlas. It is thousands of times more massive than Oumuamua and Borisov combined. Modern astrophysics cannot explain how something like this could have formed. Currently, we have 3 main theories about the origin of such comets: construction debris, leftover rubble from planet formation, the gravity of giant worlds like Jupiter fling many small bodies, comets and asteroids into interstellar space. This is the likely explanation for Borisov. Stellar orphans, objects that formed alone in clouds of gas and dust but never became bound to a star, forever wandering in the dark. Or catastrophic remnants, fragments from planetary collisions or systems destroyed by the death of their stars. The problem is that all these processes usually generate small bodies. Giants like 3I-Atlas are extremely rare. Its existence calls into question whether we truly understand how planetary systems form around other stars. The second anomaly is its strangely stable trajectory. When a comet approaches the sun, the heat causes its ice to sublimate, releasing jets of gas that act like tiny engines, altering its course. This was the case with Borisov, but 3I-Atlas behaves differently. Scientists observed it closely and discovered its path aligns almost perfectly with calculations based on gravity alone. The jets of gas and dust it emits have practically no effect on its trajectory. It's like trying to push a loaded truck by blowing on it. It doesn't even budge, but a breath can move a ping pong ball. 3I-Atlas is that cosmic truck. Its immense mass completely ignores these tiny pushes. According to what we know about planetary system formation, space should be filled with dust and small bodies. Finding a giant like 3I-Atlas is like wading into a river looking for pebbles, and on your first step, stumbling upon a huge gold nugget. Statistically, you'd need to sift through tons of sand and thousands of stones before finding one like it. But we got lucky. We found one right at the start. So lucky, in fact, that it makes some wonder, was this nugget placed there on purpose? So what is 3I-Atlas after all? There are two main hypotheses. The first is that it is an incredibly rare natural object, perhaps the nucleus of a gigantic comet ejected from its system after a cataclysm. But its extreme rarity makes this hypothesis seem unlikely. The second is that it is an artificial object. This hypothesis seems fantastic, but it would explain its anomalies. Its enormous mass and precise trajectory, unaltered by gas jets, could indicate it's not just a rock, but something constructed, perhaps a ship or a probe with a stable structure. When will we see another visitor like this? The answer is both exciting and frightening. Perhaps never. Current models indicate that bodies the size of 3I-Atlas pass through our solar system once every few thousand or even millions of years. By the time another appears, our civilization or even the solar system itself might be long gone. Why so much uncertainty? Because we only have one example, 3I-Atlas itself. We don't know if its visit was pure luck, like winning the cosmic lottery, or if our models are wrong, and large objects travel between the stars much more often than we imagine. But what if 3I-Atlas were headed straight for Earth? The mere idea sends shivers down the spine. To understand the scale of the catastrophe, let's compare it to the asteroid scientists believe wiped out the dinosaurs 66 million years ago. That one was about 10 to 15 kilometers in diameter. Our visitor is at least 5 kilometers, possibly up to 5.6 kilometers. This isn't a rock, it's a mountain traveling at tens of kilometers per second. When entering the atmosphere, it would barely slow down, heating to temperatures hotter than the surface of the sun. The fireball that appeared in the sky would be brighter than the sun itself. It would be humanity's last sunrise. The impact would release energy equivalent to tens of millions of megatons of TNT. It would form a crater 100 kilometers wide, melt the Earth's crust, and tsunamis kilometers high would wipe out coastal cities across the planet. The shockwave would devastate entire continents. But the worst would be the aftermath. Millions of tons of dust and soot launched into the stratosphere would block the sun for years, triggering an impact winter. Photosynthesis would cease, plants would die, and the entire food chain would collapse. Global temperatures would plummet by tens of degrees. The impact of 3I-Atlas would be comparable or even greater than the event that killed the dinosaurs, not because it's larger, but because of its colossal speed. Would humanity survive? It's unlikely. It wouldn't be a cinematic apocalypse, but a slow extinction. Agriculture would fail, supply systems would crumble. Only a tiny fraction of the population, sheltered in self-sufficient underground facilities, might endure.
Fortunately, this is all just a hypothesis. The trajectory of 3I-Atlas is well known, and it poses no threat. It will pass at a safe distance, but its appearance is a reminder that the cosmos is full of forces capable of rewriting a planet's history in an instant, and perhaps next time, we won't be so lucky. What if 3I-Atlas didn't collide, but landed or docked like a ship? If we set scientific skepticism aside and imagine it is a vessel, how large could its population be? If it were a self-sufficient floating world designed for a millennial-long journey, much of its volume would be occupied by life support systems, water and food tanks, reactors, and shields. The habitable areas would be protected in underground levels against radiation. With a 5-kilometer diameter, such a ship could house about 1.3 million people, enough to maintain genetic diversity for many generations. If the crew were in cryogenic sleep, or if the ship only carried genetic material and databases, the space would be used far more efficiently. It could hold up to 65 million individuals. It would be a true interstellar Noah's Ark, carrying the biology of an extinct world. Then there's the most fantastic hypothesis, yet also one of the most popular online, that 3I-Atlas is inhabited not by biological beings, but by a form of artificial consciousness. Inside, computing centers, servers, and storage systems could house digital intelligences. In that case, its population wouldn't be measured in bodies, but in minds, potentially infinite in number within the available volume. For comparison, a cryogenic ship of this scale could easily house the equivalent population of a small country like Switzerland, with about 8.7 million inhabitants. Our channel has a video that shows where 3I/Atlas came from, why it became an orphan, and what happened to its home world. Watch it via the link. Right now, Comet 3I/Atlas is at its closest point to Earth, but at the same time, it is hidden behind the Sun. Astronomers, both professional and amateur, are trying to observe it, but it's practically impossible. Our star outshines our instruments, so what is happening with our interstellar traveler remains a mystery. But soon, it will emerge again from behind the solar disk, and then we will point every telescope on Earth in its direction, watching it drift away, trying to understand what it really is. Its last stop will be Jupiter. 3I/Atlas will pass by the gas giant at a tremendous speed and may accelerate even more due to the planet's immense gravity. This force will sling it out of our solar system, sending it into the unknown depths of space toward new stars, on a journey humanity can only dream of. For now, it remains the greatest astronomical enigma of our time. It defies all expectations and forces us to reconsider what truly wanders in the deep space between the stars. As one researcher said, we shouldn't judge a book by its cover. The truth is in the data, and we have only just begun to collect it on this extraordinary visitor. This is just the beginning. If your mind is buzzing with questions, you're thinking clearly. Subscribe to NeuroFlux Hub and hit the bell icon. We're just getting started. In our next video, we're breaking down the 3 most credible theories about what 3I/Atlas really is, and the data that has top scientists questioning reality. Let us know in the comments, what do you believe 3I/Atlas is? A comet, a ship, or something beyond our current understanding? Stay curious, stay exploring. This is NeuroFlux Hub.